Welcome everyone, and I see people are still joining, so this is great. The objective, basically you all now take part of the Shipyard Academy, which is great. One of the objective is to give you a deep insight of what we are doing here at Nym, and also how you can help. But in order to help, you need to understand few things. So a lot of you already understand a lot of these concepts, but sometimes it's good to get the same level of understanding. So basically, my job today is just to make a Nym 101. For a lot of you, it will be just repeating, just hearing very simple things on things which are extremely complex. Every small topic that I'm going to talk about it, so you can drill down for hours behind in terms of ideas, in terms of tech. But so we will be very, very on the surface, but giving a big overview. So let's get started. So in terms of overview, we're going to have three main sections during this session. One will be on privacy in general, why we need privacy, why we need to build it, how we're going to build it. The second section will be on mixnet, because you heard at least that Nym is a mixnet. So we're going to drill a bit down into there. And then the last part, we're going to go down in the economics of it a bit. These are really three simple sections, and we're going to go through them. Yeah. So the first thing is about privacy. Privacy is the context we are all here for, right? We are all here because we have a sense that we do need privacy. And I'm pretty sure every one of you had this conversation with some family members, some friends, who are saying, well, if you haven't done anything wrong, you don't need privacy, right? Privacy is only for bad people who want to hide things. And we have a strong understanding of privacy, that privacy is something in a digital world that should be normal, and that everyone should be able to have it by default. So the fact that you're using the tools for something good or bad, this is another subject, which is how the society is choosing its moral norms, and it's not up to decide what this is going to be. But what we need to make sure is that everyone has the right to make its own opinion, and for this we need privacy. And you can be very quickly in a world where everything is recorded and everything is publicly available. If you say something and suddenly the morality of your society is changing, then it can come back to you, and you can be a target for something you said some time ago. So privacy, we believe, is something that everyone should have. So how do we define privacy? Privacy is a very complex concept, and there's many ways of defining it. It is the ability to, like I said, to learn, to communicate, to be able to make your own choices, to inform yourself. It's the ability also to be free of influences. You have algorithms who are trying to manipulate you all the time. If you have privacy, those algorithms, like for example, if you go on Facebook, you will see that your Facebook feed is actually modified. It's not the same experience based on where you are and who you are connected to and what are your interest. Your feed is modified, and it actually affects you. So your privacy is the ability for you to have an access which is not modified to information. And privacy is how we define in Nym is actually the ability to share, to decide to share what you want to share with who. So it's about how you disclose things. So if I'm having a discussion with someone, I am deciding what I'm disclosing to the other person, and I will only disclose some part of it, some part of my own life, and the other person will do the same. So it's about selective disclosure. And so who needs privacy? Obviously, we think everyone needs privacy, but you have real cases. You have real cases, for example, for religious minority that are being persecuted. These are real cases, right? In the US right now, there's a real case of women looking for some health advices for around abortion or other sexual type of topics, and in places where it has been outlawed, where it is forbidden now to have an abortion, and the enforcement institutions are using the social networks or are using the communication tools, or even the geolocalization of the people to find out that they were in a center like this one. So it's also people in the office environments. A lot of companies are setting up surveillance tools in the office, and whenever they say something in the office, it will be traced. So how do you report misbehavior of your colleagues? How do you report misbehavior of your own manager in a working environment? I can give you some small story. In Switzerland, even in schools, there are surveillance systems which are set up. My kids have to learn internet, how to use internet at school through surveillance system and through man-in-the-middle attack by the school sysadmin. And that's not a normal thing to be taught. Of course, we have very traditional threats, like a journalist who's in a place where the freedom of speech and liberty of journalism is not well respected. He can go to jail. He needs privacy to be able to continue his work. And journalism, media, is an important work in a democracy. So most of the time, the journalists who are not in democracies are having a lot of troubles and actually are killed every year. Businesses, if you're running a business and all your connections are being looked at, basically others can extract value, and this is in the economy that we are moving in, the decentralized economy that we're moving. Actually, a lot of the value extractions from business happens with other businesses, Uber-style business, who are basically looking at your data, looking at your behavior, and providing some services, and then sucking all this data for their own value. So if you have a private communication with your clients or with your service providers, you can actually retain more value and be in control of your business. And then we also have a lot. The society is moving into a place where people want to be themselves. People want to change their way. If someone wants to change their way of living, being transgender, being whatever they want, today in lots of places, and just even online, they can be threatened by a lot of people who don't like this behavior, and then will actually threaten them. So privacy is a way for all these scenarios, which are like very large, to protect ourselves. And what is interesting is that you can hear in the discourse, if you listen to conversation of people, actually right now the topic of privacy is coming quite frequently. I'll just give you a funny story. Yesterday, I was eating in a restaurant, and I was overhearing, let's say, a couple speaking, and they were having a good time. And but at one point, they were talking about depression, something random, and it ended up by, yeah, I'm depressed because I feel surveilled, and I have no control of what is happening. And they were giving example of how advertisement, how control of data was happening. And there was just random people who were not in the tech environment. So it is a concern for a lot of people. And what is interesting is that basically in the last 20 years, the tension has been growing because the main business model of the internet has been built around surveillance. And this is what is a very it's a great paradox that we're trying now to solve, and it's very hard to solve because all the large companies like Google, like Facebook, basically built their model in a way that they're providing free services in exchange for harvesting all the personal data and actually selling it to advertiser, analysts, or even government agencies. So there is a whole business model of surveillance, and even if we feel personally or collectively that privacy should be important, actually we are facing a whole industry which has been built around making money with what is called the digital oil, or the oil of the digital century, which is personal data. And so there is the power of business on one side and our personal opinion. And of course, usually what happens is that the power of business is usually taking over. So how do we fight that? So the first thing we can do, we can show this. We can show that this is happening. We can show the mechanism, and this is what some people did, and very heroic people like Chelsea Manning, which is working with us, who has been revealing wrongdoings of the army. But more importantly, we have Edward Snowden, who actually showed, as a whistleblower, he showed the inner working of the surveillance model of the US. And what was interesting in 2013 when he revealed this is that the mass surveillance program that was being operated by the NSA was not just a program from the NSA and the NSA trying to do stuff. It was actually a mixture between collaboration with other agencies, with companies, but also attacks. So at the same time, the big corporation were part of the system, and at the same time they were also a victim of a system. So it's a very perverse, system, and there's some companies who are playing on that, like Peter Thiel's companies. So whistleblowing, like Edward Snowden did, is something that is core, alright, also in the fight for privacy, because you need to show what people are doing, and in the digital world, showing and making understand what is really happening to the data and to our world is something which is very difficult, because something digital, you cannot see it. You have to experience it or to understand how technically it works behind. So people are paying a very high cost to be a whistleblower. So from there, how do we work on this in terms, like, in something which is more sustainable? And we have been working already on privacy through the angle of pure cryptography. So we can hide the data. We can make what is called end-to-end encryption. We can use, for example, Signal, which is a great tool for communication. Actually, even WhatsApp is using the same protocol as Signal, so you can encrypt the message between the people is actually encrypted. So that means that the content of our communication is pretty secure, let's say. And on the web, when you're browsing on the internet, you notice that since several years, all the websites have a HTTPS. They have an S at the end of the HTTP, which means there is a end-to-end encryption between your computer and the server. So this is good. There are some attacks around this. You can do man-in-the-middle attack, like they do in especially a lot in Middle East. You can attack the devices that you're using. So like what the Western countries are doing with programs like NSO or these kind of programs. And but this is already good. But what we discover is that the fact of encrypting just the data, making sure that the communication content is not known by the people who are looking at you, this is not enough. Actually, there is much more data that you can infer, that you can analyze if you are looking at the metadata. The metadata, which means is the knowledge of who is sending what data, who is communicating with who at what point, at one point. So how do we solve that part? And one thing I think is important is that we are building privacy through using anonymity tools. So we need to build anonymity tools. We need to make ourselves invisible in this ocean of data. In this ocean of anonymity, we have to hide ourselves between a lot of other people, and then we can start communicating really privately because our communication becomes non-observable. So this is why we say privacy loves company. And this is our motto right now in Nym. Privacy loves company because we need to be a lot of people to hide our communication between ourselves. And the larger we are as a group of people, and the more undistinguishable from each other we are, then the better anonymity we have, and the better privacy we have. I'll just give you an example. If you're all alone, or if let's say you're communicating, you two of you, you're walking outside, you're on the square of your city, and you're all alone in the middle of the square. Everyone can see both of you talking. Maybe you're far away, they cannot hear you, right? Because you have like an encrypted communication, or it's very far away. And it's okay. They don't hear what you're saying, but they can see that you're both talking to each other. And how long, and if you're angry or not, they can see that. Let's say now that you have around you 10 people, and we're still observing you. It's getting a bit more complicated to see that you're talking to each other, but it's okay. In a group of 10 people, we can see, and I can tell, yeah, you see the couple who is arguing there between the group of 10 people. We can find out. But suddenly, all those 10 people, they all wear black T-shirt. And they all wear hats, and the same hat. Then, can you see the two-person arguing? Which one? The one with a hat. Oh, they all have a hat. Oh, the one with the black T-shirt. Oh, they all have a black T-shirt. And now imagine you have suddenly 1,000 people on the square, all with black hat and black T-shirt. Right, so that's becoming more complicated. And then you have 10,000 people, and they're all arguing to each other randomly. So the people who are really having a discussion inside there, it's getting much more complicated to find them. So this is the concept of gaining true privacy, is to make sure that we are lost and that we are hidden in a sea of anonymity. All right, but now this is the ideal concept. How do we go and actually build that? So we're going to move to the second section, which is about basically the mixnet. So The mixnet, first, we're on the internet. And the internet is made out of layers. So the technical people here will go, yeah, there are 7 layers. But we'll go more in a conceptual way, right? We're not going to go in the real layers of the internet. We'll go on the conceptual layers of the internet. And there's basically a network layer is a place where all our communications, whenever you are connecting to a website, you are communicating with someone on a messaging app, there are some packets that are going through the network, right? And these packets, they are reaching a destination, which could be the computer of the other person, and they are going through a different sets of servers. They can be in different technical layers of the internet, but they all move, right? It's all data. Right now I'm speaking to you, the data goes from my computer through my Wi-Fi. There's the Wi-Fi router, and then it goes to a server, which is managed by the ISP, the Internet Service Provider, of where I am. Then it's routed through the internet, through the what we call the internet. So it's routed through big servers, and finally it reaches your ISP. It first goes through Discord servers. So first it goes with Discord servers. You're connected there also. Then it goes back to you through your ISP, and finally it reaches your home. So all these connections, there are some communication packets that are going through, and every actor which is in there can see those packets moving in and out, and they know the route. So my ISP right now knows that I'm talking with Discord, and your ISP the same. Maybe you're using a VPN, maybe you're using some kind of tool, but even if you're using a VPN, your VPN provider knows that you are connecting on Discord right now. So how do we build a sea of anonymity, like I was explaining before, over a network layer where every packet follows a very precise route and can be monitored and can be moved in a very precise way? And actually, they need to move it in a precise way to actually, so that the packets reach destinations, because obviously my voice right now needs to go to the Discord server. Otherwise, you wouldn't be able to answer it. If my voice would go somewhere else in the void, it wouldn't be very useful. So what we do, we create an overlay network. What is an overlay network? Is that based on this existing network of packets that are communicating through the internet, and we send them at a very precise destination, we are building basically a network of computer, and we are basically, instead of sending the packets over the internet in the normal way, we are sending it through another network, which is built on top of this system. So instead of sending my packet through directly to the Discord server, I will send it to a specific computer, which is in our case a gateway, and then the my communication will take another route until the Discord server, in a way that it's encrypted, but also in terms that it's mixed in terms of size, and also in terms of the speed, where it's a bit slowed down, and the destination takes a lot of different hops. So at the end, when it reaches the Discord channel, the Discord server, anyone who has been observing the network have no clue of what had just happened, because the message was sent in a completely disorganized way, or it seems disorganized way. So Harry, the CEO of Nym, likes to say always, it's like shuffling a deck of cards. So if my packets of data are like cards, like a game cards, when you're playing those game cards, and you need to shuffle them. So basically, I have a set of packets of data of like communication messages that I want to send. I write one message on each card, and I give this packet of card to someone, and he receives also messages from other people, and he just mixes the deck of cards. Like when you're playing, you're giving out a new set of the game, and you're just like mixing the cards, and then you're giving the cards to someone else, and he mixes again, and so on. And so this is exactly what is happening with our packets, our data packets on the mixnet. So why does a mixnet help for privacy? Because it creates over the network layer. So over the network layer that we explained, we have an overlay network, which is our mixnet. And then if someone is watching this, if someone is trying to understand who is communicating with who, then they cannot make sense of it. They cannot read who is sending to who, because every time I will be sending a packet through the mixnet, I will be mixed with all your packets in the same place, and then it will go out somewhere to Discord, the Discord back server in my case. But someone who's watching the Discord, the whole my communication or the communication around the data center of Discord cannot say it comes from me. So even if someone is watching the whole network, it is not possible for them to understand who's talking to who. So basically what a mixnet does provide, if it's well done, because it's still a complicated technology, it allows to avoid God mode. So you're playing a game, especially like a map world, and at one point you always have the God mode where you can see everything. There's no more fog of war. Basically, the God is the one who can see everything, and we need to protect ourselves from this. And this is the design. This is the threat that Nym that the mixnet is trying to answer. So who invented mixnet? That story, I think it's pretty an amazing story, because it's one of the oldest concepts which exist on the internet. It dates from 81. So it was David Shom, which is a very famous engineer, and it's a very famous engineer, and he works still today. He works on the internet. And he published this paper about mixnets in 1981, because even at that time it was clear that privacy was going to be an issue. But it was so early that there was a lot of pieces missing. So the design was, the concept was imagined then, but then it took actually 40 years to come to a point where we can actually build something which works. And so that's why we are building it now, 40 years after, because we needed a lot of missing pieces. But there is a way. It's not that this concept was invented at that time and implemented today. There was a lot of tests and a lot of build-ups until now. And it's a bit, and the story even is a bit mixed with the story of Bitcoin, because the first big usage of a mixnet, or the first implementation that existed for a mixnet, was called Mixmaster, which was an anonymous remailer. So a remailer is a way to send emails to someone else, and that was back in the years 2000. To send an email to someone else without revealing where we are on the internet. The problem is that if you do this, you get a lot of spam people who are sending spams. They want to hide themselves also, and they want to find computers who are allowing them to send emails. So to avoid this, basically the remailers who were using mixnets had to protect themselves against misuse of spam. And Adam Back, that some of you might know, and if you don't know him, also Google him up. Adam Back, who was maintaining one of those anonymous remailer, had to invent something to force the spammers to make sure that for the spammer it would be really costly to send an email. So he invented the proof of work, what is called hash cash. He invented proof of work that is being used today in Bitcoin to actually protect a mixnet against spam attacks. So you see, there's a very interesting connection. There's some connections with the Bitcoin world, which is, I think, fantastic, because this is exactly how the developments of privacy tools is happening. We have an idea at one point, and then we try it out, and we try it again, and then we mix it with things which we didn't thought about it, right? Oh, let's use a mixnet to do emailing. Oh, then we invent something for that is fighting spam. This is being used to make Bitcoin, and then we will see it back afterwards. Then what Bitcoin invents, then we can use it again into the Nym mixnet world, because we need some business logic which was invented thanks to Bitcoin. So what is Nym? Nym, our project, Nym is basically a mixnet. So that is one version of a mixnet. And it's a decentralized one, and the aim is simply to provide privacy on the network layer. So basically, right now, after these 40 years of research, and the team, the Nym team has been part of this research for sometimes. If you look up the name, if you look up Claudia Diaz, if you look up Andrei Sergentov, our CTO, CFO, sorry, if you look up Anya, if you look up George Denises, our advisor, and all the advisors that we have, if you look up Harry, what he's been doing, everyone has been working on pieces of the puzzle that allows us to build a decentralized mixnet that can provide privacy at the network level. So why did we call it Nym? And I think that's also quite important to know why we use a specific term. And actually, a Nym is a name which has a meaning and an existence. So obviously, it comes from. It's the same Nym that you hear in anonym or in pseudonym, right? Nym in Latin means the name. And so it was already used in computer science as a pseudonym that you can use online to cover your identity. So it's a technical way that was used again in the Mixmaster remailers. We had things called Nym servers, and so basically you were getting kind of like a pseudonym identity that you can use, and then you can act on behalf of this Nym identity. So the name is already there for some time, and obviously it's also a name that's associated to pseudonym and to anonymity. And so people understand when we are saying we're talking about Nym as projects, and that Nym is providing privacy through building anonymity tools, an anonymity layer. I think people understand naturally the link between privacy and anonymity when they hear the word Nym. And this is also, like, I think, one of the important aspects that we are pushing in terms of the narrative. When we're building a project with all of you in the community about something, it's also about what is the understanding of those words. Do we understand each other? And the people that don't know about what a mixnet is, that don't know about technology but are using technology and will be our main users in a couple of months and years. They need to have this understanding that when they're using Nym, they're using something which is providing true privacy through anonymity tools. And I think the Nym name can definitely help. So what is Nym? Is it a VPN? People will ask you the question, oh, but yeah, I know about hiding myself on the internet. I use a VPN. Is Nym like a VPN? No, not really, not really. A VPN is very good at bypassing your geolocalization, right? So, for example, you're in France and you want to do some streaming of videos, and this is highly forbidden in France. You can get your internet shut off because of this. You can use a VPN, and then you're in another country which doesn't care. This is what people do. In some countries, VPN is very useful because there are some websites you cannot go because they are censored. So even in Switzerland, we have some weird censorship. So we have some cryptocurrency websites which are censored by DNS, and you can use a VPN to go through. And obviously, in some countries, pornography is forbidden, so all the pornography websites are not available, and people still want to see them, so they're using it, an VPN. So it's very sorry. It's good to bypass this, but in terms of privacy, it doesn't really help because you can see that you're using a VPN, but also if the VPN company itself knows exactly what you're doing. So if there is a collaboration between the VPN and an enforcement company, they will still be able to see what you were doing. Nym on the other side is actually obscuring your IP address. So like when you're communicating through the mixnet, there's no way for the person to understand where is your IP address, but also what is the metadata that is being used. That means that we cannot find where you are on the internet. The VPN doesn't protect you from this. So some people will say, well, there is Tor. Is the Nym mixnet like Tor? That's a good question too, that we hear. Tor is a great project, right? Tor is like the first network that really provided a lot of help for people and for journalists and for a bunch of people who needed protection. It's a very old technology, and sadly, it reaches now a point which is hard to move on for many reasons. Because of the old technology they're using, they should like redo everything. Because of the design, and there are some like weaknesses which now have been spotted, and the Tor network is much more similar to a mixnet than a VPN, but the design was meant only to hide the IP address. So you were supposed to hide your IP address to the person you were going to talk to. But what Tor doesn't do, it doesn't protect you from the analysis that the God view. If someone is God on the internet, they can see your traffic going through Tor, and they can analyze the pattern of your packets, the speed of communication, and they can correlate from which point you are entering the network and from which point you're leaving the network. And Tor was never designed to protect itself from this attack, because when Tor was designed, there was no way no one could be God on the internet. But today, the God mode is actually much more affordable. NSA can do it, but also some corporations can actually pay for it. It's getting reasonable and achievable for a lot of people. what we see also is that a lot of people in the crypto community are using Tor. For example, if you have a Bitcoin node, you can connect it to Tor. It's included. There's a lot of wallets which have a Tor function. But in reality, chain analysis companies now are collaborating with companies who can de-anonymize Tor, and they can actually see a lot of, they can gather much more data than you think. So when there is an interest and there is a money to be paid for, there is a way to de-anonymize Tor. All right. So now we go to the last section, which is something which is really new in the in the thinking of this world where we are trying to provide privacy tools. And it's the business side of it. It's the economical side of it. Until now, Tor, which is a very good tool and is based on the peer-to-peer, and we are using, everyone here, there's a lot of us using it, has no business model, or if it has one, it's called altruism. So basically, a lot of you donated to Tor, and money goes into a foundation, and this foundation is funding the development of Tor. Which is good, but it has some limits, and it has a size limit at one point. Because the amount of money they can collect is very minimal, and compared to the massive surveillance industry, which we talked about at the beginning. There's a huge industry. They have a lot of money, and they spend a lot of money to de-anonymize things like Tor. So what changed in the 40 years that we had of development of mixnets and privacy tools and anonymity tools? What changed is that we have the whole token economy that appeared thanks to Bitcoin and then Ether. And you had a lot of work and a lot of thinking behind this. So basically, we designed Nym with a token. And so, yes, Nym has a token, and it's a very specific type of token, which is called a utility token. Why is it called a utility token? Because it has a specific objective that actually this token will at one point, this is not live yet, at one point it will allow you to actually open up the gates of the mixnet. So it will be a paid for system. Why we think a paid for system will work is because we can see already that people are using VPNs, for example, and there is a market for VPN, and especially in the new digital world where crypto economy and cryptocurrency are slowly getting normal. Paying for something in a cryptocurrency is becoming is soon going to be very normal, and so paying the right price for the right service, I think it's fair to design a system like this. So today, if you want to design something like this, you need a token, and in our case, it's a utility token. So why do we think we need a token? So one, there's the business model, of course, and we see this as an alternative to the business of surveillance. So there is two businesses that are existing now. There's a main business of surveillance where we are providing service for free in exchange of you being surveilled, and we are taking all your data and reselling it. And on the other side, there is there is a new economy which is building actually on providing security that you are paying for with a token, but where no private data is being shared. So basically, first we need a token to make to have a business model which can sustain the whole economy. But the second thing, which is very important, is that in a mixnet, one of the weak points of Tor, actually, which is not a mixnet, but they have the weakness is the same. You need to have a reputation system in place in order to fight against an attacker. So if someone wants to attack a mixnet, like the Nym mixnet, you need to gain a large proportion of the network, to control a large proportion of the network. And it has been already seen in many different cases that if you have a reputation system, you can incentivize good actors to remain in place for a long time enough that the attack is becoming too costly and doesn't prevail. So this is exactly what you are all doing if you have a bit of tokens and you are delegating those tokens to a mixed node. You're actually giving them reputation because you know them. You can observe them from some time. You can say, oh, this node is performing well, so I will delegate to him. Oh, he's not performing anymore. I will undelegate and move my tokens to someone else. Right? So all these things that you are already doing right now, the day there is an attack, the day someone is trying to actually attack the system and needs a lot of token to have all these nodes with high reputation, well, the first thing they need to do is they need to buy a lot of tokens. Then they need to convince all of you to delegate to them. It's going to take a lot of time. And as soon as you realize that they are attackers, then you can undelegate, and they would lose that would make the attack much more expensive than just buying some tokens and running a lot of mixed nodes. So if we're talking about if we're talking about tokens, then we need to talk about blockchains, because a token today, best scenario, it runs on a blockchain. And is Nym, the mixnet, a blockchain? No, it's not. So we have to be very, very precise. And also, it's very important to understand the difference between the Nym mixnet, which is a network of computer which is just sending packets to each other, and they're not supposed to record any packets. It's just like traffic, sending traffic and mixing and providing the privacy. And on the side, we have a blockchain. The blockchain, we call it the NYX blockchain, NYX blockchain. And this is where the token is located. So when you do a transaction, it happens on the NYX blockchain. But this is the place where we operate the reputation system and the reward system, so to pay everyone. Right? So it's two different things: the Nym mixnet on one side and the NYX blockchain on the other side. But they are connected together, right? So they're connected because if you are operating if you're operating a node, you need to register on the blockchain. But if you're a simple user, at the end, if you're a simple user, you might never actually touch the blockchain at all. And so, very important question. A lot of people are saying, "Oh, yeah, but blockchain is great to. It's a public ledger, so we can. It's very useful to share information and to store information." And some people want to make blockchains for digital identities and put all personal data on the blockchain. And basically, that's a really, really bad idea. That's a really bad idea. So on a blockchain, you don't put data you want to secure. You register only information that needs to be publicly available. It's a public ledger. So for example, for us, we are using it to show the topology. So we can show the state of the infrastructure. All the list of all the nodes are registered on the blockchain, but the traffic itself, to be private, you are using the mixnet. You're not using the blockchain. And same, then you'll see that in the code base that we have, there's a lot of software. And one of the software we have is called a wallet. And this is the first piece of software that we built. I mean, from a user perspective, we have a wallet. Actually, we have a lot of other pieces. We have the core pieces of the infrastructure that many of you know. We have the clients, we have the mix node, we have the gateway. But the first UX, the first type of software that people can just download and run on their computer right now is called the wallet. So what is the Nym wallet for? So the Nym wallet is like a cryptocurrency wallet. It's the way to interact with the blockchain of Nym, the Nix blockchain. And it allows you to send and receive Nym tokens. It allows you to delegate to a mix node. So if you have Nym tokens and you want to increase the reputation of someone or reduce the reputation of someone, you can do it through the mixnet, the wallet, sorry. And if you are a node operator, you can actually bond your nodes using the wallet. So it's going to be it's kind of a dashboard for another node operator also. It's your main tool to be able to connect your mix node to the whole mixnet, and other tools will be there. So yeah, so that was kind of an overview of the three main elements. So to finalize with the economy is that we build Nym with an actual business model, and it's not a business model which is a traditional one, because it's a business model which is linked with a whole community where everyone is some are paying, some are incentivized to provide resources, and some people are paying for using those resources. It's kind of so that's my personal view. I see it sometimes like a big cooperative of like hundreds of people running this, maintaining and running this network, and all our interactions are managed through the token on the blockchain, and the service that we provide is the mixnet itself. So at the end, the users will come, and of course it could be us. I mean, we are the first user of our own system, but some of the users will actually never see Nym in the way we see it. They will use one of your apps. Maybe you are an app developer yourself, and you will just allow the integration of an app with Nym, and people will be using Nym, and you will providing actually credentials so that people can actually even you can pay for your own users to use the Nym network. And why do we think also companies will pay for it? Because right now they're losing so much in terms, it costs so much to manage private data, that we believe that a lot of companies and a lot of people will actually pay a little bit for something like Nym and VPNs and some other privacy technology to basically reduce the cost of managing the personal data, which is becoming too high. So, right, I think I went through a bit all the points I wanted to go through. Just like a small outro, let's say. We're going to, and this is more like a small thing about Nym right now. We will have a lot of developments in the coming weeks happening. In terms of like the code base and not new tools, but like improvements. So like stay tuned also on how the tools are going to evolve, because it's going to be pretty interesting in the coming weeks for us. So yeah, pseudonym, I'll give it back to you.
Nym 101. I'm going to be using this and linking this around once we uploaded the recording. Absolutely huge. Thank you very much, sir. Now, what's your schedule like for the rest of the day? Do you have time for some community questions? Because we have quite a few pretty great questions from the community.
Yeah, no, I have all the time, guys.
Awesome. All right, let's get to it then. So we have two questions which I think can be treated as one, basically. So one is whether Nym can turn out like a tornado cache, and the other is who or what can hinder Nym in its development, maybe some laws or sanctions. I think these two questions are basically one.
Very good question. Very good question, because this is a concern for us from the beginning. And but this is where also, again, I said at one point that we are a whole team, and everyone has a small piece of function in there, and we all bring something. So tornado cache seems similar, but actually there's like some fundamental changes with it, right? The big difference between tornado cache and mixnet is that tornado cache was designed as a financial mixer. This is the only thing you can do with it. It was a financial mixer. Nym is a data. It's a generic data mixer. You can send anything through it. Right? So we're not designing a financial tool mixer, and this is not the purpose actually of Nym. Can you help making some financial transaction more private thanks to Nym? Yes, you can, but it's not going to change. For example, in the case of tornado cache, you could see a Ether address using tornado cache, and they were targeted. So that's whole happening on chain, and it wouldn't change. So what it means by this, when we say that tornado cache was designed as a financial mixer, it means it goes into the jurisdiction of financial regulators, because then they said, hey, well, you should have been a regulated entity. As in the Nym mixnet, it is like Tor. Basically, we're much more in that sense in terms of legality or regulatory space. We're like Tor, and we're providing an overlay network on the internet, and this is in most of the world something which is unregulated, and Tor hasn't been the target of I mean, there's been some attacks, but not legal attacks on Tor per se. So
For a good reason, right?
and for a good reason, exactly, and for a good reason. That was the last point. For the good reason is that actually in governments are very paradoxical too, because some of the institutions want to destroy anything which is related to privacy, but a lot of them needs privacy too. Think about the military. Think about some type of institutions, health institutions. They need the privacy to protect themselves. So they are using Tor, and they will be using Nym, or they will be using a mixnet, and hopefully they will be using Nym. So at one point, governments cannot kill Tor because they actually need it, and we need to come to the point that government will be using Nym the same way, and they won't be able to kill it. So I hope this answered the question.
It does. So legally speaking, if you start regulating something like Nym, then you're basically also regulating something like VPNs. And if you would regulate or limit the use of VPNs today, then basically most corporations would collapse tomorrow and would leak all their stuff immediately, because VPNs are very central to most corporations, in protecting their data. So Nym in that sense is very safe.
Absolutely. And also, like there's other things. We build this from Switzerland. It has a reason also behind this. Switzerland is a very strong place for privacy-oriented projects. I'm Swiss. I'm a known person in Switzerland. if they would, I mean, in the local Swiss network, it wouldn't environment, it wouldn't make sense to start harassing me for these kind of things. That's an example, right? But there's a lot of small pieces like this of that we do. We also have a project which is very much audited, very much public. We don't have any secrets. Our accounts are audited over 4 years now. Even though all the financial part of it, like the token there has been a prospectus been published, which has been audited too. So we are pushing the limits of transparency in the traditional legal framework to a level which has been unheard of. So so these are all layers of protection that we are doing. We're protecting ourselves through transparency, especially within Switzerland.
A whole strategy built along those lines, targeted at protecting ourselves. Now, on to the next question. I think it's also a good one. So NIM's mixnet design ensures network anonymity and anti-surveillance, but can an attacker who performs packet capture at the customer's network be able to analyze the packet?
Sorry, can you repeat what kind of attack?
Yeah. So performs packet capture.
Yes, packet capture. So this is yeah. So basically, packet capture is a technique which is being used by actually, it was already used by I think NSA or some agencies where regarding PGP. When maybe some of you remember PGP. Pretty good privacy. It's still being used, and it's a bit rough on the UI and on the UX. But basically, it's used to encrypt emails. But it has one big flaw that now has been solved. I mean, not on this product, but it has a flaw. Is that we always reuse the same key, so you're encrypting the messages always with the same key. And if you're and so what the agencies did is they said, well, we're going to record any communication that someone is sending. We're just going to keep it if it's encrypted. And then maybe one day we will be able to break the key. And once we break the key, then we can read all the communication of the person, but also in history we can go backwards, right? We can look at all what he's been saying. So this is a potential attack on him. So you look at the mixnet and you record everything that you see, and you basically keep a copy of the whole traffic of the mixnet that you see. All right. So, but now, how do we fight this? And there's many ways, right? And I think there's already few elements which exist in the mixnet that can answer a bit of the, kind of this. So first, the size of the mixnet. We are going to spread the mixnet around with mixed nodes in a lot of places, in a way that it's going to be harder if the data go through all these different networks, different service provider, to make sure that someone can capture everything. Okay, if all the NIM mixed nodes are with AWS, in the same data center, it's pretty easy to record everything. But if it's spread around the world, it's making things a bit more complicated. So I think then you will never reach 100%. And if you don't reach 100%, you might actually miss the important packet. So that's one answer. The second answer is that every hour we have a new epoch on the mixnet, and every hour the keys of the mix node are changed, or no, maybe sorry, I don't want to say something stupid, but I mean there is a time. So I don't know if it's every hour. There's a time where the keys are changed in every mix node. So basically, what we can do there's so you need to you will be only if you're capturing everything. You need to break several keys for the same server. So it's getting more complicated. And then also what we can do, because we're only moving packets forward, at one point, if we think that the cryptography that is being used to encrypt those packets during the communication is too weak, we can change it and make something stronger, right? So we can change how the cryptography works, and so at least we protect for the much more for the future. So there's many these are like some of the things which makes it pretty hard for someone who would copy everything and then hope for one time to in the future to actually decrypt everything, to be able to do that.
I think an important addition to this, which is related, is the fact that in the mixnet, the mixnet was built fundamentally to so no party in the mixnet, no actor in the mixnet trusts the other, and it was built like that on purpose. So nobody has all the pieces that they need to actually de-anonymize someone. That you would have to have a lot of different actors of the mixnet cooperating in a very specific way to be able to do that. Which ties into our next questions, I think, pretty well. What does the gateway know about the user who wants to mix through the mixnet?
So the gateway is the only compute machine in the whole network that knows the IP address of the user. I think this is very important to understand because this is one of the key part of the mixnet. So first, maybe let's say what does a gateway do? Right now, we didn't put a lot of focus on the gateway. There are a few of them are running. They're a very simplified system, and there are going to be a lot of work on the gateways to come, and there will be a lot of changes, and the role will evolve quickly. Basically, the gateway is this kind of mailbox. If you are a user and you have a client on your computer which is connecting to Nym, you will connect to a gateway, and there you have a mailbox. So you can deposit packets, you can deposit your communication there, and then it will be picked up and sent to the mixnet. And you will also receive the packets in your mailbox at the gateway, and you can come and pick them up, right? So you have this address. You have an address. You are connected to this gateway, and this is also the gateway that will be in the future checking if you have paid or not, if you have enough credit to use the mixnet. That will be checked by the gateway. So the gateway is an important piece of thing. It doesn't understand what you're talking to or what the data, because the data is already encrypted. The data is already cut into small pieces. So and the gateway can basically be used by many people, but it knows your IP address. And that's why there's going to be work which will come, which we already started, but will come more in the future. How to make sure that the connection between the client, the user, and the gateway is also very much secure. What it means in terms of security and threat models, it means that someone who's watching you as a client or someone who's watching the gateway cannot say what you're talking about and who you are connected to. That is, they cannot say, but they can see that you're using the Nym mixnets. That's the only thing they can understand, and they could potentially shut you down because of this. So we have to work on that threat in the second stage, because it was not part of the original. I mean, it's not something that we're building the mixnet. At first, this is something which is a type of threat which is common to all the other systems. It's the same for the VPN, it's the same for the Tor and other systems.
And this is part of the reason why we like to say anonymity loves company, or privacy likes company, because because the more things the fact that you're using the mixnet can mean, the less people can know about what you're using it for. So if all traffic on the mixnet is completely homogeneous, so it looks the exact same from the outside, if more different types of things are happening on the mixnet, it is very, very hard to figure out which one of those things someone is actually doing.
Yeah, this very good thing, very good point. It's like we are going to work. We are working on like in the future we on big integration, and as soon as you have like major, for example, apps, you're on your phone, and you have major apps which are really common apps, sometimes stupid app, right? Like imagine, I know it's not even a communication app, but like let's say your train app. Your train app where you can look the train and maybe you can pay for your train. It's not something which is which is in the eye of the storm when it comes about privacy and defending the internet, whatever. But if they are implementing Nym, then you would have Nym traffic coming out of your phone, and which means that if you are running another app, which is a messaging app, where you actually need privacy and it's running Nym, well, the operator or the observer cannot tell the difference between the two apps. And I think that that is going to be one of the key of making sure that Nym mixnet is usage is ubiquitous enough in for some even stupid apps, which have no where there's no challenges in terms of privacy. Even if they use Nym, that will help the other. Privacy loves anonymity. No, sorry, privacy loves company. Privacy loves company.
But but also anonymity, probably one is predicated on the other, so you're not wrong about that.
Yeah, yeah.
Now, just so everybody knows, there's also going to be one of these upcoming lectures is going to be a network deep dive. So a lot of these questions are going to be answered in much more detail there. And I'm not sure whether this is a good question for you, Alexi. So please tell me if it isn't. But when we're talking about Tor, or you were talking about Tor, someone asked, speaking of Tor, how will Nym tackle the issue with exit nodes? Because most Tor exit nodes are already blocked on public internet servers. So what can we do about that? I guess this also ties into the conversation about gateways, because the equivalent of a Tor exit node would be a Nym gateway.
Well, not really, not really, not really. Because the design of the mixnet is a bit different than the one of Tor. On Tor, you have computers. You connect to an entry node, and you can go out on an exit node, right? So in Nym, you have the mixnets in the middle, and then you have gateways on around them. So you first need to connect to a gateway. You discuss through Nym, and it goes through another gateway, and then another client on the other side needs to connect to that gateway. Which means that if you want to rebuild an exit node, the same thing that it does over Nym, technically it is another computer that connects to a gateway. So you have two inbound connections. You don't have one inbound and one outbound. You have me as a user. I'm connecting to the mixnet, and the exit node. What you want it to be the exit node is actually a client which is connecting to the gateway. So it's another user in the network. The Nym mixnet doesn't see the difference. So there is no mode by default. So it will be fully the responsibility of the person providing that specific service. I think that's the key. You cannot build an exit node by accident. You are building an exit node by design, because you want it, and then you need to be careful on this. So there's some jurisdiction, like in Switzerland, if you are open about your exit node, most of the provider will say, well, okay, good, you're the one, you're responsible enough to manage the reputation of your IP address. That's fine. In some countries, it might be giving problems. So that needs to be sorted out. But then what we hope happens is that basically people will understand that the exit node, like you have in Tor, is actually not the fun part. It's not the thing that we want to reach. We might replace those ones, or we might help improve those ones. But the thing is, instead of create an exit node for the whole internet, you're you're connecting your own servers directly to the mixnet. So basically, you don't need to have an open gateway. You can use a specific service, like you're providing an app with a backend. You will connect your backend to Nym network, and so the traffic will never leave the Nym mixnet. I think this is more powerful than a simple exit node.